Integration of SpaceX's Starship in 2024, critical milestones in funding allocation for interplanetary missions. Overview. In 2024, SpaceX's Starship is poised to transform interplanetary exploration, supported by a significant funding allocation of $3.2 billion. This initiative is structured around 5 critical milestones that aim to enhance the Starship's operational capabilities and facilitate humanity's exploration of destinations such as Mars and the Moon. Milestone development. 1. Milestone overview. The integration of Starship into interplanetary missions involves 5 essential milestones. Completion of full-scale testing. Initial testing phases will include comprehensive flight tests and landing simulations to evaluate the Starship's performance in real conditions. Regulatory approvals. Securing necessary regulatory approvals from aviation and space authorities is vital for operational readiness. Supply chain enhancements. Improvements in supply chain logistics and manufacturing processes will ensure the readiness for mass production. International collaboration. Building partnerships with international space agencies including NASA to leverage global expertise and resources. Initiation of mission-specific launches. Launching initial missions targeting lunar and Martian exploration will mark the culmination of the integration process. These milestones are critical for ensuring that Starship can effectively support both crewed and uncrewed missions. 2. Funding allocation. The $3.2 billion funding is allocated across various facets of Starship's development. Research and development, investment in new technologies and enhancements to existing systems. Infrastructure improvements, upgrading facilities and equipment necessary for testing and assembly. Operational readiness, ensuring that all systems are go for upcoming missions including safety testing and regulatory compliance. This substantial financial support is expected to catalyze rapid advancements in technology and manufacturing processes. Accelerating SpaceX's timeline for interplanetary missions. Key points of consensus. Various sources highlight the significance of Starship in future space exploration. Common themes include interdependence of funding and development. The technological advancements and successful milestone achievements are closely linked to the funding provided. International collaboration, emphasis on partnerships with organizations like NASA is crucial given the complexity and scale of future missions. Divergent perspectives. Different sources present varying focuses on the Starship's integration. Technical specifications. Some sources delve into detailed engineering challenges and technical specifications of the Starship. Strategic implications. Others highlight the broader strategic importance of Starship's deployment in the context of global space exploration initiatives. Regulatory hurdles. Discussions around regulatory challenges and necessary safety testing also vary, with some sources providing detailed timelines while others maintain a broader overview. Timeline of events. The timeline for Starship's integration into missions is as follows. Early 2024, completion of initial full-scale testing including flight tests and landing simulations. Mid-2024, expected regulatory approvals from relevant aviation and space authorities. Late 2024, enhancement of supply chains and manufacturing processes to ensure readiness for mass production. End of 2024, launch of initial missions targeting lunar and Martian exploration. Conclusion. The integration of SpaceX's Starship represents a transformative step in space exploration, underscored by substantial funding and a structured approach to overcoming both technical and regulatory challenges. Successfully achieving the outlined milestones will significantly shape the future landscape of interplanetary travel and exploration. Sources. 1. Canadian Space Agency 2023-24 Departmental Results Report. 2. Various space exploration forums and publications discussing Starship and its role in future missions. This report encapsulates the critical elements surrounding the integration of SpaceX's Starship in 2024, highlighting the Milestones funding allocations and broader implications for interplanetary missions. The successful execution of this plan will not only advance technology but also enhance collaborative efforts in the realm of space exploration. 1. Integration of SpaceX's Starship. The integration of SpaceX's Starship for interplanetary missions presents a counterintuitive narrative regarding the relationship between technology and funding. While one might expect that more funding would directly translate to faster technological advancements, the report indicates that milestones such as regulatory approvals and supply chain enhancements may take precedence over the mere allocation of funds. The timeline emphasizes that certain foundational steps need to be achieved before funds can be effectively utilized, suggesting that the process of integration is more complex than a straightforward correlation between funding and progress. 2. Funding allocation. The allocation of $3.2 billion specifically for the development of Starship highlights an interesting paradox in the aerospace sector. Immense financial resources are often required to overcome bureaucratic and regulatory hurdles. Instead of a linear path to success, the funding is aimed at addressing multifaceted challenges including safety testing and international collaboration. This implies that financial investment in aerospace is not only about technology development but also about navigating the intricate web of regulations and partnerships, which may slow down the pace of progress rather than accelerate it. 3. Common key points versus differing perspectives. The contrast between sources focusing on either technical specifications or strategic implications provides a counterintuitive insight into how success is measured in space exploration. While technical achievements might seem like the most critical indicators of progress, e.g., flight tests, the strategic implications of collaboration and regulatory navigation are equally vital. This suggests that successful space missions may rely more on diplomacy and regulatory finesse than on technological prowess alone, challenging the conventional wisdom that emphasizes engineering and innovation as the primary drivers of success. 4. Regulatory approvals and safety testing. The emphasis on regulatory approvals and safety testing is crucial. Milestones may counter the common assumption that technological readiness is the primary focus for launch timelines. The fact that these bureaucratic processes can delay missions underscores the importance of patience and meticulous planning in aerospace endeavors, where regulatory compliance can be as significant a hurdle as the engineering challenges. It highlights a reality where safety and legal frameworks can sometimes overshadow technical readiness, leading to a more drawn-out timeline than one might initially expect. 5. International collaboration. The report mentions the necessity of collaboration with international partners as a key element in the integration of Starship. This highlights a counterintuitive aspect of space exploration. While one might assume that competition drives progress, the reality is that collaboration can often be the critical factor leading to success. The need to work with other nations and agencies introduces complexities that can slow down timelines, suggesting that the path to successful interplanetary missions is less about a race to be first and more about building consensus and partnerships. 6. Timeline of events. The structured timeline for Starship's integration indicates a surprising level of predictability in an industry often characterized by unpredictability. The step-by-step milestones provide a framework that contrasts with the common belief that aerospace projects are inherently chaotic and subject to frequent delays. The methodical approach with clear markers for testing approvals and production readiness implies that with the right planning and resources, successful integration can be achieved within anticipated timeframes, challenging the notion that aerospace projects are perpetually behind schedule. 7. Technological advancements versus regulatory compliance. The expectation that technological advancements will naturally lead to successful missions is countered by the reality of regulatory compliance. The report illustrates that even with cutting-edge technology, the success of missions depends heavily on meeting stringent regulatory standards. This indicates a broader lesson in the aerospace sector. innovation must be tempered with compliance and safety considerations, suggesting that the path to success is more intricate than simply developing advanced technology. 8. Funding versus operational readiness. While the significant funding allocation of $3.2 billion might imply that SpaceX is ready to launch immediately, the reality is that operational readiness encompasses more than just financial resources. The integration of Starship requires a series of preparatory steps, including testing and regulatory approvals, which may delay immediate launches. This counterintuitive observation underlines that financial support is necessary but not sufficient for operational success in complex aerospace projects. 9. Collaboration versus competition. The focus on collaboration with international partners adds another layer to the counterintuitive narrative surrounding space exploration. While competition among private companies like SpaceX and traditional agencies like NASA is often highlighted, the report emphasizes that successful interplanetary missions may rely more on collaborative efforts. This suggests that the path to human exploration of Mars or the Moon is not solely about outpacing rivals but rather about leveraging shared expertise and resources to achieve common goals. 10. Sustainability and greening efforts. The Canadian Space Agency's initiatives to incorporate sustainability and environmentally friendly practices into its operations present a counterintuitive perspective in the heavily technology-driven space sector. While one might assume that space exploration is inherently resource-intensive and environmentally detrimental, the emphasis on greening efforts and sustainable practices indicates a shift towards responsible exploration. This challenges the traditional narrative that views space missions as disconnected from environmental concerns, showing that ecological awareness and space exploration can coexist and even enhance each other. These points illustrate the complexities and nuances of space exploration, where expectations may not always align with reality. The integration of SpaceX's Starship in 2024 underscores the multifaceted nature of advancing humanity's reach into space, where funding, collaboration, regulatory navigation, and technological readiness all intertwine in unexpected ways. The report on SpaceX's Starship integration in 2024 outlines significant milestones in funding allocations that are crucial for advancing interplanetary missions. While the key points are often highlighted, several important aspects might be overlooked by the general audience. Here are some of these elements, along with an explanation of their significance. 1. Regulatory approvals and their implications. The milestone concerning regulatory approvals is frequently underestimated. Achieving these approvals from relevant aviation and space authorities is not merely a bureaucratic step, it represents a substantial challenge that can delay timelines significantly. The significance lies in the fact that regulatory frameworks are evolving as private spaceflight becomes more common. SpaceX must navigate complex international regulations which can impact the speed and feasibility of future missions. Delays in regulations may not just affect SpaceX but could set precedents that influence global space exploration policies, affecting other companies and national space agencies. 2. Supply chain enhancements. The report highlights supply chain enhancements as a critical milestone. This is often viewed as a logistical necessity, but its deeper implications include resilience against global supply chain disruptions that have been exacerbated by events such as the COVID-19 pandemic. The ability to streamline the supply chain translates to faster production times and cost reductions, which are crucial for maintaining competitive pricing in the burgeoning space market. Moreover, efficient supply chains can enhance innovation by allowing for rapid prototyping and testing of new technologies. 3. International collaboration. The report emphasizes international collaboration but does not delve into the strategic benefits of such partnerships. Collaborating with other space agencies and countries can yield not only technological advancements but also geopolitical advantages. It can foster goodwill and shared learning, potentially leading to joint missions that can pool resources and expertise. This collaboration is significant in the context of global space governance and may pave the way for collective responses to challenges such as space debris and planetary defense. 4. Funding allocation specifics. While the $3.2 billion funding allocation is a headline figure, the specifics of how this funding will be utilized are crucial. Many people may overlook the targeted areas for investment such as R&D and infrastructure improvements. Understanding the allocation can reveal SpaceX's strategic priorities, whether they're aiming for rapid technological advancements, enhanced safety protocols, or infrastructure expansion. This funding allocation indicates how SpaceX positions itself within the competitive landscape of space exploration and can influence its long-term viability and innovation capacity. 5. Impact on human resources and talent acquisition. The report briefly touches on human resources but may not emphasize the implications of workforce growth within SpaceX and the broader space industry. The projected increase in hiring reflects a commitment to not only scaling operations but also investing in talent acquisition and retention strategies, which are crucial for sustaining innovation. This aspect underscores the importance of fostering a skilled workforce that can meet the demands of increasingly complex space missions and technological advancements. The cultivation of talent in the space sector can also have a ripple effect on education and employment in science, technology, engineering, and mathematics STEM fields. 6. Technological development and its broader implications. The relationship between funding technological development and milestone achievement is emphasized but could be further explored. Technological advancements in the Starship program may have applications beyond space exploration, potentially impacting terrestrial industries such as energy, transportation, and materials science. Innovations developed for interplanetary travel could lead to breakthroughs with far-reaching implications for Earth, including enhanced sustainability practices and new materials with unique properties. 7. Mission-specific launches. The initiation of mission-specific launches, particularly for lunar and Martian exploration, is a critical milestone that signals a shift from theoretical planning to practical implementation. This step is significant because it sets the stage for testing operational capabilities in real-world scenarios. Successful mission-specific launches can validate SpaceX's technologies and methodologies, providing crucial data that can enhance future missions. They also serve as a demonstration of capability to potential partners and clients, boosting confidence in SpaceX's ability to deliver on ambitious interplanetary goals. 8. Cultural and societal impacts. Finally, the cultural and societal implications of SpaceX's Starship integration might be overlooked. Successful interplanetary missions could shift public perception of space travel from a distant dream to a near-future reality. This paradigm shift could inspire a new generation of scientists, engineers, and enthusiasts, significantly impacting educational pursuits in STEM fields. Additionally, the societal conversations surrounding space exploration, including ethical considerations, planetary protection, and the potential for colonization, are becoming increasingly relevant as missions become more ambitious. Conclusion. In summary, while the integration of SpaceX's Starship for interplanetary missions in 2024 is framed around several critical milestones and substantial funding, the nuances of these elements hold significant implications for the future of space exploration, international collaboration, and technological advancements. Recognizing these overlooked aspects can provide a more comprehensive understanding of the challenges and opportunities that lie ahead in humanity's quest for interplanetary exploration. 1. Milestone framework for SpaceX's Starship integration. The successful integration of SpaceX's Starship into interplanetary missions is structured around 5 critical milestones. These milestones include the completion of full-scale testing, obtaining necessary regulatory approvals, enhancing the supply chain, fostering international collaboration, and initiating mission-specific launches. Each milestone is essential for ensuring the operational capabilities of Starship for both crewed and uncrewed missions to destinations like Mars and the Moon. A detailed analysis of each milestone can provide insights into the technical and regulatory challenges that SpaceX must navigate, the implications for international space collaboration, and the potential impact on future interplanetary exploration. 2. Funding allocation and its strategic importance. The $3.2 billion funding allocation is pivotal for the development and operational readiness of Starship. This funding is earmarked for various aspects, including research and development, infrastructure improvements, and technological advancements. An in-depth discussion of how this funding can accelerate timelines for interplanetary missions, enhance technological capabilities, and support the growth of related industries can shed light on the broader economic implications and strategic positioning of SpaceX and its partners in the global space sector. 3. International collaboration and its role in space exploration. The emphasis on international collaboration is a key point in the discussion around Starship's deployment. Partnerships with agencies like NASA and other international space programs are critical for achieving shared goals in space exploration. Exploring the dynamics of these collaborations, their potential benefits, and the challenges they may face can provide a comprehensive understanding of how international relations are evolving in the context of space exploration. This analysis can also highlight how collaborative efforts can lead to shared technological advancements and cost efficiencies. For regulatory and safety challenges, the process of obtaining regulatory approvals and ensuring safety is a significant aspect of Starship's integration into interplanetary missions. The varying focus across different sources on regulatory hurdles and safety testing presents an opportunity for deep analysis. Understanding the regulatory landscape, the specific challenges SpaceX faces in meeting safety standards, and the potential consequences of delays in regulatory processes can help frame the broader discussion on the necessity of robust safety protocols in advancing space exploration. This analysis may also touch upon public perception and its impact on regulatory frameworks, emphasizing the need for transparency and stakeholder engagement in the space sector. 1. Apollo 11 moon landing 1969. The Apollo 11 mission is one of the most significant milestones in human space exploration. On July 20, 1969, astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the moon, while Michael Collins orbited above in the command module. The mission was the culmination of years of research, development, and funding from NASA amounting to billions of dollars, which was critical for the success of the Apollo program. Apollo 11 demonstrated the effectiveness of international collaboration in science and technology and inspired generations to pursue careers in STEM fields. 2. Mars Exploration Rover Program 2004-present. NASA's Mars Exploration Rover Program, which includes missions like Spirit and Opportunity launched in 2003 and Curiosity launched in 2011, represents a series of critical milestones in robotic exploration of Mars. These missions have significantly advanced our understanding of the Martian environment, geology, and potential for past life. The funding for these missions has reached billions, with each rover's design, construction, and operation contributing to the broader aspirations of interplanetary exploration. These milestones underscore the importance of technological advancements and international partnerships in achieving complex space missions. 3. International Space Station 1998-present. The International Space Station ISS represents one of the most significant collaborative efforts in human space exploration. Launched in 1998, the ISS is a joint project involving space agencies from the United States, NASA, Russia, Roscosmos, Europe, ESA, Japan, JAXA, and Canada, CSA. The station serves as a microgravity laboratory for scientific research and has facilitated international cooperation in space exploration. Funding for the ISS has involved billions of dollars from participating nations, showcasing the importance of resource allocation, technological innovation, and collaborative frameworks in maintaining a permanent human presence in low Earth orbit and conducting research that benefits humanity. In 2024, the integration of SpaceX's Starship is poised to significantly influence interplanetary exploration, backed by a $3.2 billion funding allocation aimed at achieving 5 critical milestones. This initiative represents a transformative leap in space travel technology and international collaboration with the potential to shape the future of humanity's presence beyond Earth. 1. Milestone Overview. The integration of Starship will focus on 5 essential milestones. Full-scale testing completion. Early in 2024, SpaceX aims to complete all initial full-scale flight tests, including landings and reusability assessments. Successful tests will validate Starship's design and operational capabilities. Regulatory approvals. Mid-2024 is targeted for obtaining necessary regulatory approvals from aviation and space authorities, ensuring compliance with safety and environmental standards. Supply chain enhancements. By late 2024, improvements in supply chain logistics and manufacturing processes will be critical for scaling production and ensuring timely delivery of Starship components. International collaboration. Throughout 2024, SpaceX is expected to strengthen partnerships with international space agencies, including NASA and other global players, fostering collaborative missions and shared technology advancements. Mission-specific launches. The end of 2024 will see the initiation of the first mission-specific launches focusing on lunar and Martian explorations, which will set the stage for future interplanetary missions. 2. Funding allocation. The $3.2 billion funding allocation is pivotal for several key areas. Research and development. A significant portion of the funds will be directed toward advancing the technology behind Starship, including propulsion systems, life support, and reusability enhancements. Infrastructure improvements. Investments will be made in launch facilities, ground support equipment, and testing infrastructure to ensure readiness for increased launch cadence. Operational readiness. The funding will also support operational training for crewed missions, ensuring that both the astronauts and ground teams are prepared for the complexities of interplanetary travel. 3. Common key points. Across various analyses, several key points emerge regarding the importance of Starship. Technological advancement. There is widespread agreement that Starship is a critical innovation in space travel technology with the potential to revolutionize how missions are conducted. International partnership. The focus on global collaboration emphasizes a collective approach to space exploration, pooling resources, knowledge, and capabilities for greater mission success. Interdependency of efforts. The relationship between funding, technological development, and milestone achievement is underscored as essential to the success of interplanetary missions. 4. Differences between sources. While there is consensus on the importance of Starship, sources diverge on several aspects. Technical specifications versus strategic implications. Some sources highlight the engineering challenges and technical specifications of Starship, while others focus on the broader strategic implications of its deployment in global space exploration initiatives. Regulatory challenges. Variations exist in the depth of coverage regarding regulatory hurdles, with some providing detailed testing and launch timelines while others offer a more generalized view of the challenges. 5. Timeline of events. The projected timeline for Starship's integration into missions is as follows. Early 2024, completion of initial full-scale testing validating design and operational capabilities. Mid-2024, anticipated regulatory approvals from relevant authorities ensuring compliance with safety standards. Late 2024, enhancements in supply chains and manufacturing processes for mass production readiness. End of 2024, launch of initial missions targeting lunar and Martian exploration, setting a precedent for future interplanetary travel. Future outlook. The successful integration of SpaceX's Starship by the end of 2024 is expected to herald a new era in interplanetary exploration. As these milestones are achieved, the following predictions can be made. Increased frequency of space missions. With the operational capabilities of Starship, there will likely be a marked increase in the frequency of both crewed and uncrewed missions to the Moon, Mars, and beyond. Expansion of commercial space activities. The reusability and cost-effectiveness of Starship may lead to the rise of new commercial opportunities in space, including tourism, mining, and scientific research. Strengthen international collaboration. The collaborative framework established through partnerships will likely pave the way for more comprehensive international missions involving a wider range of nations and space agencies. Technological innovations. Continued investment in R&D will yield breakthroughs in propulsion life support and robotics, which may have broader applications on Earth and in other sectors. Preparation for permanent human presence. The groundwork laid by Starship missions will enhance humanity's capability to establish a permanent presence on the Moon and Mars, setting the stage for future colonization efforts. In conclusion, the integration of SpaceX's Starship in 2024 represents a pivotal moment in humanity's journey into space, driven by significant funding and a structured approach to overcoming technological and regulatory challenges. The successful achievement of these critical milestones will not only reshape interplanetary travel but also redefine our understanding of what is possible in space exploration.